In the previous section, we learned all about how Modbus memory is arranged in devices that are Modbus compliant. In this section, however, we will be looking at how Modbus compliant devices in a network communicate with one another. The Modbus protocol on any network operates in what is referred to as a request and respond system. Let's look at an example to illustrate this request and response system. Let's say that there are two PLCs connected on a simple Modbus network, PLC A and PLC B. PLC A has a problem. It needs to get a data value from PLC B. So what PLC A will do is send a request to PLC B, a request message, asking for the particular data value. PLC B will then respond with the data value. In this scenario, PLC A is operating as what we call a Modbus master in the network, and PLC B is operating as what we would call a Modbus slave in the network. It is extremely important that you will remember and fully appreciate this master-slave relationship on the Modbus network. And now here's another extremely important concept. In a network composed of multiple Modbus compliant devices, there can be only one master. The remaining devices will all be slaves. The Modbus master makes requests of the Modbus slaves. That's how Modbus network operates. The master will send a request of a slave and the slave will respond. A slave never initiates a conversation. So 100% of all the conversations happening on a Modbus network happen because the Modbus master initiated it. Furthermore, once a device is configured as the master on the network, it stays as the master. No other device can temporarily become the master on the network. They will always be Modbus slaves.